Alright, so today I'm going to show you guys how to do stoichiometry. We start out with 5 grams of magnesium added to 10 grams of hydrochloric acid, which will make magnesium chloride and hydrogen gas. To figure out how many moles of magnesium we start with, we need to divide the 5 grams by the molar mass of magnesium, which is 24.31, and that equals 0.21 moles of magnesium. Same process is required for hydrochloric acid. We take 10 grams and divide by the molar mass of 36.45, and that equals 0.27 moles of HCl. To figure out the limiting reagent, we take 0.21 moles of Mg and 0.27 moles of HCl. Then because it is a 1 to 2 ratio, we multiply 0.21 by 2 and divide by 1, which equals 0.42 moles. This will make HCl the limiting reagent because we need 0.42 moles but only have 0.27 moles. Because HCl is the limiting reagent, Mg must be the excess material. To figure out how many moles of excess we have, we take 0.27, multiply by 1, and divide by 2. This equals 0.135. Then we subtract this from 0.21 to get 0.075 moles of excess. We then multiply this number by the molar mass of magnesium to get 1.82 grams of excess. Next, we are going to see what quantity of H2 we will end up with. We divide 10 grams by the molar mass of HCl to get 0.27. Then because it is a 2 to 1 ratio, we multiply by 1 and divide by 2 to get 0.135 moles of H2. Then we multiply that number by the molar mass of H2 to get 0.27 grams of H2. The same process is required to figure out the quantity of magnesium chloride. Since it is still a 2 to 1 ratio, we get 0.135 moles of magnesium chloride, but then we multiply by the molar mass of 95.21 and get 12.85 grams of magnesium chloride. To find the oxidation states of the compounds in the equation, Mg is going to have a 0 charge, H is going to have a +1, and Cl a -1. On the right, Cl is going to have a -1 charge, so magnesium must have a +2 charge to balance it out. Then H2 is going to have a 0 charge. Because Mg went from 0 to +2, it was oxidized, and because H went from +1 to 0, it was reduced. To find the percent composition of magnesium chloride, we take 1 mole of magnesium and 2 moles of Cl and divide them each by the molar mass of magnesium chloride, which is 95.21. We then multiply those numbers by 100 to get 25% magnesium and 75% chlorine. We are now going to figure out the empirical formula of a compound that is 20.19% magnesium, 26.64% sulfur, and 53.17% oxygen. We take each of those numbers and divide them all by their molar masses, and then take the smallest number and divide all the numbers by that number to get 1 magnesium, 1 sulfur, and 4 oxygens. This will give us magnesium sulfate, MgSO4.